Hi, in the previous video, we have talked about the theory and onto the code. The best way to understand numeric objects and expression is to see them in action. So with those basics in hand, let's start up the interactive command line and try some simple but illustrative operations. So let's exercise some basic math. We first assign two variables a and b to integers so we can use them later in the large expressions. So what variable is? So variable are simply names created by you or Python that are used to keep track of information in your program. So in Python, variables are created when they are first assigned values. Then variables are replaced with their values when used in expressions. Variable must be assigned before they can be used in expression, and variable refer to the object and are never declared ahead of time. So in other words, these assignments cause the variable a and b to spring into existence automatically. So for example, if you assign a to 10 and b is equal to 20, so this name is created a. So let's use our new integer object in some expression. So here a is equal to 10 and b is equal to 20. So at this point the values of a and b are still at 10 and 20. If you want to see, you can print a, b is equal to 20. So variables like these are replaced with their values whenever they are used inside the expression, and the expression results are echo back immediately when we are working interactively. So for example, if you want to give a plus 1, so it will give 11. If you give a minus 1, it will give you 9. Similarly, if you do multiplication, so b into 3, it will give 60. So if you want to divide b by 2, it will give 10.0. So in Python 3, whether you are using integer or a floating point, the result always be the floating point. If you want to make it as an integer, you have to give like this. Similarly, this will give you the reminder. So for example, if you want to see what will be the reminder, 11 divided by 2, it will give 1. If you want to give a power of 2, it will be 400 because the value of p is 20 and we are giving the 20 power 2. You can also give the expressions like this. So the results being echoed back here are tuples of two values because the line typed at the prompt content, because the lines type at the prompt contains two expressions separated by comma. That's why the results are displayed in parentheses. Note that the expression work because the variable a and b within them has been assigned some values. So if you use a different value that has not been yet assigned, Python report an error rather than filling some default values. So for example, we have earlier defined a and b. If you want to do some operation with a variable x, so it will give an error. So here we can see it's giving a name error, that name x is not been defined. So to make it work, like if you define a name as 2 and if you perform the same operation, this will success. So in Python we don't need to pre-declare variables, but they must have been assigned at least once before you can use them. So it's not like that the other programming languages like C, where we need to define the variable first, then we can use to assign some values and then we have to use them in our expressions. So we don't need to pre-declare the variables in Python, but they must have been assigned at least once before you can use them. Here are two slightly large expressions to illustrate operators, grouping, and more about conversions. A is divided by 2 plus b. Here value is 25. So here it divides a by 2 and then add b. And let's perform the same when we include that in a parenthesis. Parentheses are added around the plus part to force the Python to evaluate it first. So let's talk about some numeric display formats. Numeric display formats. So let's take num is equal to a divided by 2.0 plus b. If you print num, it will give this long floating point number. So the full story behind this odd result has to do with the limitation of the floating point hardware and its inability to exactly represent some value in a limited number of bits. So for example, we can also see this as this one 4.545455E hyphen 01. If you want to limit the number, the floating point number, you can give your expression like 4.2f so it will limit the floating point for 2 digit. 3 digit you have to give the 3. So the number of precision points you want, you can give after the point. And also there is other format option. These all are the way you can format your text. So same for 2 digit floating point number, you can give your number like this. Comparison. So far we have been dealing with the standard numeric operations like addition, multiplication, division. But numbers, like all Python objects, can also be compared. Normal comparison work for numbers exactly as you have expected. They compare the relative magnitude of their operands and return a Boolean result, which would normally test and take action in a large statement in the program. So here are some examples for the comparison, like if 1 is less than 5, it will return true. If 20 is greater than 6, it will also return true. We can also give relatively comparison. If 2.0 is less than or equal to 4, it will return true. Whether if you can also compare a floating point number to an integer 1.0 and 1, it's true or not. Similarly, we can also check 1.0 is not equal to 1.0, so it will return false. So Python also allows us to change the multiple comparisons together to perform a range test. Chained comparisons are sort of shorthand for large Boolean expression. In short, Python let us string together magnitude comparison test to code chained comparison, such as the range test. So for example, let's take a is equal to 10, b is equal to 20, and c is equal to 30. So we can give a is less than b is less than c, it will return true. If we can say is a is greater than b is less than c, it will return false. So what it will do, it will check each and every expression. For example, first it will check if a is greater than b. So we can see a is 10 and b is 20, so a cannot be greater than b, but b is less than c, that's true, but the whole expression is false, so it returns false. In same fashion, we can give a is greater than 4.0, b is, and 4.0 is less than b, and b is less than c, so it will return true. So in the same fashion, we can use these comparison operators in our expressions. So division. Basically there are two types of division. One is true, another is floor. True division, what we see in the maths, like a is divided by b. For example, if we divide 5 by 2, it will give us a result of 2.5. But if we will use floor in Python, we will use this double slash. So for example, if we give 5 by 2, floor division of 2, it will return 2. Here we can see 5 divided by 2, it will return 2.5. But if we give a floor division, it will return 2. So the true division always keep reminder in floating point result regardless of the type. But when we do the floor division, this always truncates fractional reminder down to the floor. regardless of the type. It results type dependent on the type of the operands. So we can say this always performs the true division and return a floating point number that include any remainder regardless of their operands. So either we can use an integer divided by a float, or integer divided by an integer. It always returns a floating point depending upon the regardless of the operands. But the float division, which truncates the remainder and return an integer operand, or a float if the operand is float. So if the operand is integer, its result will be integer, and if the operand is float, result will be float. So we can see here, if we give 5.0 divided by 2, it will return 2.0. Now floor versus truncate. So the floor operator, informally called truncating division. So but it is more accurate if we refer this as a floor division. It truncates the result down to its floor. Truncate the result down to its floor. So which means the closest whole number below the true result. The net effect is to round down, not strictly truncate, and this matters for negatives. You can see the difference of yourself with the Python math module. We are importing math module, and if we do math.floor, we want to give 3.5, it will return 3. And if we do math.floor for negative 3.5, it will return 4. And same if we do math.trunc for 3.5, it will return 4. But same if we give negative 3.5, it will return 3. So when running division operator, you only really truncate the positive result, since truncation is same as floor. But for the negative, it's a floor result. Really, they are both floor, but floor is same as truncate for positive. So if you really want to truncate towards 0 regardless of sign, you can always run float division through math.trunc. So that's all for this video. In the next video, we will also continue Python numeric type and operations. So thanks for watching and stay tuned.